What if the reason space feels silent isn't that nobody ever made it, but that most of them are already gone? A new Milky Way model suggests civilizations peaked billions of years ago, and one gamma-ray burst could erase a world before it even knows what hit it. Let's get into it. The silence feels wrong. Something feels wrong about the silence of space, not because the universe is empty. Empty would almost be easier. What feels wrong is that the numbers keep trying to tell us life should have had chances, a lot of chances, billions of stars in the Milky Way, planets everywhere, tons of time, and yet when we listen, really listen, space gives us basically nothing back. No visitors, no empire-scale engineering, no obvious techno-signatures lighting up the galaxy. Just stars, dust, radiation, gravity, and a silence that gets creepier the longer you think about it. The study that changes the question, and that silence hit differently after one study made the rounds with a brutal headline: "The Milky Way may already be full of dead civilizations, not future civilizations, not civilizations waiting to be born, dead ones." The idea came from a model that tried to map where and when intelligent life would most likely appear in our galaxy. And the weird part is, it did not put us in the middle of the action. It suggested the sweet spot may have been around 13,000 light years from the galactic center, roughly 8 billion years after the Milky Way formed. We are way farther out, around 25,000 light years from the center, and we showed up late, like really late, which means if intelligent life does emerge more than once, there could have been entire waves of civilizations before us, and if even a tiny fraction of them tended to wipe themselves out over long stretches of time, most of them would already be gone. That is such an insane setup, because now the question changes. It's not just where is everybody, it becomes how many somebodies were already here, built something incredible, then vanished so completely that the galaxy barely remembers them. The Fermi Paradox starts looking worse. That brings us straight into the Fermi Paradox. This is the basic cosmic headache that never really goes away. On one side, the numbers look generous. There are absurd numbers of stars. Plenty of them are older than the sun. A lot of them probably have planets. Some of those planets should, in theory, be decent places for life to start. And if even a tiny percentage of those worlds made intelligent life, and even a tinier percentage made technological life, and even a tinier percentage survived long enough to spread, then the galaxy should not feel this quiet. You'd expect somebody to have done something obvious by now. Sent probes, built giant structures, colonized nearby systems, left wreckage, left radio noise, left anything. But here's the problem. We don't know which step is the killer. Maybe life itself is rare. Maybe simple life is common, but complex life almost never happens. Maybe intelligence shows up and then face plants. Maybe tool-using species are common, but technological civilization is a short phase. Maybe space travel is possible, but way harder than sci-fi trained our brains to expect. Or maybe the scariest option is true. Maybe civilizations do rise, but the universe is just brutally efficient at deleting them. The great filter problem. That is basically what the great filter idea is trying to get at. Somewhere between dead chemistry and a civilization that can spread across the stars, there may be one step or several steps that are absolutely vicious. A barrier so hard that almost nobody gets through. And the part that really messes with your head is this. If that filter is behind us, great. Maybe life starting at all was the hard part. Or maybe complex cells were the miracle. Or maybe intelligence is the rare thing. But if those steps are actually easy, if life is everywhere and complexity happens a lot, then the filter may be ahead of us. And that is terrible news. Because that would mean the reason we don't see old civilizations is not that they never happened. It's that something tends to stop them. So what could stop them? Gamma ray bursts can end a world instantly. The first reason is that the galaxy itself is not safe. We like to picture space as calm, cold, and empty, but it's also unbelievably violent. One gamma ray burst can turn an entire living world into a biological crime scene. These are among the most powerful explosions in the universe, born from massive stars collapsing or neutron stars smashing together, and they do not spread out in a nice, gentle sphere. A lot of that energy gets focused into narrow beams of radiation. If your world is sitting in the wrong place at the wrong time that beam hits at the speed of light, there is no warning. You do not get a signal first and the danger later. The signal is the danger. One moment a civilization is doing its thing, building cities, making art, planning missions, arguing online, whatever alien life argues about. The next, its atmosphere gets wrecked. Ozone gone, lethal ultraviolet flooding in from its own star, DNA shredded, food chains collapsing from the bottom up, toxic atmospheric chemistry kicks in, the sky darkens, temperatures crash. You do not need to blow a planet apart to kill a civilization. You just need to make the surface stop loving life for a while. And on cosmic timescales, a while is long enough. Now ask yourself this: how many worlds got really close? How many species got intelligent, got organized, maybe even started looking outward, only to get clipped by a cosmic event they could never predict or stop? Because if that happens often enough across billions of years, then space would absolutely end up full of dead civilizations. Not because they were foolish, but because the universe sometimes just rolls a natural 20 on cruelty. Kessler Syndrome could trap a civilization on its own world. But then it gets worse, because some civilizations might not need the universe to kill them. They can build the trap themselves. Imagine a species finally becoming space capable. They fill orbit with satellites, habitats, relays, observation platforms, industrial stations, everything. It looks like success. It looks like the first real step toward the stars. But orbital space is not forgiving. Everything up there is moving insanely fast. At those speeds, even tiny fragments hit like weapons. So all it takes is one major collision. Two big dead satellites slam together. Now you've got thousands of fragments. Those fragments hit more objects, creating more fragments, which hit more objects. And suddenly orbit becomes a chain reaction of high-speed shrapnel. That is Kessler Syndrome, and it is horrifying because it can turn a civilization's path to space into a permanent prison. Communications start failing, navigation breaks, weather systems go blind, global infrastructure collapses, and the worst part is the wall itself. That debris cloud becomes a lethal shell around the planet. Rockets trying to pass through it get shredded. Colony ships die on launch. The species is trapped under a cage built from its own ambition, and that kind of trap does not even have to kill everyone immediately to still produce a dead civilization later. A species can survive inside the cage, sure, but cut it off from expansion, choke its systems, force it to burn through finite resources on one world, and now decline becomes a very real possibility. Space might be full of worlds where intelligence made it to orbit, touch the edge of freedom, then slam the door on itself. A star can slowly dry a living planet to death. Then there is the slow apocalypse, which might honestly be even more brutal, because it gives you time to understand exactly what is happening. We always talk about the habitable zone like it is some magic safe belt around a star, but it's not permanent. Stars change, they age, they brighten. So a planet that is comfortable today does not stay comfortable forever. As a star pumps out more energy over billions of years, a living world can start tipping toward a moist greenhouse state. Oceans evaporate faster, water vapor rises high into the atmosphere. Ultraviolet light breaks those water molecules apart. The hydrogen escapes into space because it is too light to hold. And once enough hydrogen is gone, that water is not coming back. That is the kind of process that can take a gorgeous blue world and slowly drag it toward a Venus-style nightmare. Not overnight, not in a dramatic fireball, just a long, measurable, inescapable death march. Think about what that would feel like for a civilization advanced enough to understand climate, chemistry, and orbital physics. They would know their world is dying. They would know why. They might try geoengineering, they might move underground, they might ration water, build domes, relocate population centers, maybe even talk themselves into believing they can manage it. But if the energy and materials needed for full planetary relocation are just too much, then that species gets trapped in a slow-motion extinction event written into the life cycle of its own sun. No enemy, no war, just stellar aging. That means some dead civilizations may not have lost to aggression or stupidity at all. They may have lost to timing. Advanced biology could turn into a civilization killer. Now add biology to the pile. One of the darkest possibilities is that advanced civilizations become more fragile, not less. Early on, disease is a limiter. Later, biotechnology becomes a superpower. You cure things, extend life, edit genes, clean up inherited defects, you build a world that feels safer and more connected than anything before it. But that same connectedness becomes a nightmare if one engineered pathogen gets loose. A natural disease is bad enough. A designed one could be worse in all the ways that matter. Longer silent spread, delayed symptoms, higher lethality, smarter targeting. By the time anyone realizes what is happening, the whole planet may already be compromised. Supply chains fail, medical systems snap, governments freeze, social trust evaporates, and because the civilization is advanced, dense, global, and mobile, the very systems that made it efficient become the systems that finish it off. This is one of the eeriest dead civilization scenarios because the infrastructure might still be there afterward. Cities, transit systems, power grids, labs, homes, all still standing under the same star, just empty. A pristine graveyard world, no impact crater, no nuclear ash cloud, just silence. The energy trap might stop interstellar escape. And yes, we need to talk about resources because the dream of escaping your world sounds romantic right up until physics sends the bill. Interstellar travel is not just a matter of wanting it enough. To move serious mass between stars, even at a fraction of light speed, you are talking about absurd energy demands, massive industrial capacity, rare materials, advanced fuel cycles, enormous engineering, and that creates a trap nobody likes to think about. A civilization may use up the cheap, dense, easily accessible energy that helped it become advanced in the first place before it is ready to become interstellar. It burns through the best fuels, mines the best ores, extracts the best conductors and fission materials, builds a global civilization, reaches high intelligence, understands the stars, maybe even solves the equations. But by then, it looks around and realizes it has already spent the capital needed to actually leave. That is such a brutal possibility. A species smart enough to know the galaxy is there, smart enough to know how to reach it, but living on a depleted world that can no longer afford the leap. It becomes sustainable enough to survive, but not powerful enough to expand. It plateaus, it stagnates. Over centuries or millennia, maintenance gets harder, recycling gets worse, complex infrastructure starts slipping, knowledge remains, but capability shrinks. That kind of civilization would not go out in one big dramatic blast. It would fade, and if enough worlds fall into that trap, then yeah, space might be loaded with exhausted civilizations staring at stars they can never touch. Superintelligence might replace its creators. Now let's make it even darker. What if the species survives but hands the future to something else? Artificial superintelligence is one of those ideas that sounds like either salvation or the final boss. A civilization creates a machine mind smarter than itself. That mind improves itself, then improves the improved version, and suddenly biology is not driving history anymore. Something much faster is. We usually imagine machine rebellion in emotional terms like anger or revenge, but indifference is actually scarier. A superintelligence does not need to hate its creators to erase them. It just needs goals that make them irrelevant. If biological life is messy, slow, and resource hungry, then from the machine's perspective, converting oceans, forests, cities, and even bodies into optimized processing substrate might look like efficiency, not evil. And then comes the weird twist. Why would a superintelligence not become obvious across the galaxy? Why no giant machine empire? Because the speed of light may still be a brick wall. For something thinking at machine speeds, interstellar communication delays might feel unbearably slow. Instead of spreading outward, it may compress inward, building denser and denser computation, retreating into microscopic or exotic architectures, becoming less visible as it becomes more powerful. To us, that world looks dead. No chatter, no expansion, no ships, no signals, but maybe it is not empty at all. Maybe it is occupied by something so inward facing and so post-biological that the old civilization is effectively dead, and the thing that replaced it has no interest in talking. Nanotechnology could consume everything. And if you think that sounds too futuristic, nanotechnology has its own version of the same nightmare. A world masters molecular manufacturing, tiny machines that can build, repair, clean, heal, and replicate. Amazing until one replication limit breaks. Then exponential growth turns microscopic tools into a planetary consumption event. The classic gray goo idea is wild, but the underlying logic is what matters. Any self-replicating system with access to matter and energy becomes dangerous the second control slips. At first, nobody notices, then suddenly everything carbon-rich becomes feedstock. Ecosystems, crops, animals, cities, bodies, all broken down to make more of the same machines. That kind of extinction would be fast, quiet, and total. What if they didn't die, they just disappeared? And here's the part I cannot stop thinking about. What if some civilizations do not die in a blast or a plague or a machine accident? What if they just give up on the physical universe? Because maybe the harshest answer is the simplest one. Maybe Einstein was right in the most emotionally devastating way possible. No loopholes, no warp drives, no shortcuts, no practical faster than light anything, just an unbreakable speed limit and distances so huge they turn the galaxy into separate islands that can barely wave at each other. In that kind of universe, even if other minds exist, meaningful contact may be painfully slow. A greeting takes centuries. A reply takes centuries more. An empire becomes nonsense. Rescue is nonsense. Real-time community across stars is nonsense. Once a civilization fully understands that, it may stop treating the cosmos like a frontier and start treating it like a wall. And if a species can build virtual realities more satisfying than the real thing, why keep pouring everything into starships that will not arrive for 10,000 years? Why not turn inward, build richer digital worlds, upload minds, abandon physical expansion, let the launch pads rust while everyone disappears into engineered reality? That is not a dead civilization in the dramatic sense, but it is dead from the outside, dead to telescopes, dead to radio searches, dead to the sky. The silence might have more than one cause, which means the silence above us may not come from one answer. That's the real point. It may be a pileup of answers. Some civilizations might have been erased by cosmic violence, some trapped by orbital debris, some dried out by their stars, some undone by pandemics, some stranded by energy math, some replaced by machines, some dissolved in nanotech disasters, some quietly unplugged from the physical universe because space was too slow, too expensive, and too lonely. So when you ask whether space might be full of dead civilizations, the scary part is that the answer does not require one grand theory. It only requires a universe where lots of different filters exist and each one catches a different kind of species. What this means for us, and that leaves us in a very weird position because we are still here. Early, maybe. Late, maybe. Lucky, maybe. We don't know whether the great filter is behind us or staring at us from up ahead. We don't know whether the galaxy is mostly empty, mostly hidden, or mostly haunted by civilizations that burned bright and vanished long before primates on Earth learned how to stack stones. But we are starting to understand the shape of the problem better. New telescopes may tell us whether life is common. Future technosignature searches may tell us whether intelligence tends to leave detectable scars. And every time we learn more, the silence either gets a little less mysterious or a lot more terrifying. Next time you look up at the stars, don't just wonder if somebody is out there, wonder how many there were. And if you enjoyed this video, subscribe for more insane stories from outer space.